Hi, good morning. This is Mr. Willis, and I'm going to talk with you today about metric units, metric conversions, and a technique and tool called dimensional analysis. So let's dive right in. When we talk about the metric system is based on powers of 10. And so that actually makes it very convenient to switch back and forth between one metric unit and another. In customary units that we use in English, switching from inches to feet to miles, it's all different multiples and different conversion factors, whereas in the metric system, it's all a power of 10. And so that's part of what makes the metric system so convenient and one of the reasons that we like to utilize it for science and other measurements. Okay, so as we talk about the metric system, it is also based on a system of prefixes and then roots. And so the prefixes are going to be things like kilo, as in kilometer, milli, as in millimeter, centi, as in centimeter. And so those are going to be some prefixes that you'll encounter. And then your root words are going to be your root units or your base units. And that's going to be things like meter, liter, and gram. Now, as we look at our prefixes, there are many other prefixes that could come into play. So those are not the only prefixes that are available. And of course, these are not the only roots, but meter, liter, and gram tend to be the three most common that you will encounter. All right? So, and of course, the gram is the unit of mass. The liter is a unit of volume. And a meter is a unit of length. All right, and so that's a quick introduction to those root words, to those base units, and what they are used to measure. All right, so let's dive right in then in terms of what how those can fit together. So let's say that I would like to measure a distance, and that maybe I have a distance of 1,500 meters. All right, but perhaps I would like to express that a little differently. And so we're going to look at the relationship between kilometers, millimeters, centimeters, etc. So you just keep in mind up here that I've said that I have 1,500 meters, and we will adjust that into some other units based on different prefixes. First, let's talk about the prefixes. And I'm going to make a list of a few common prefixes. Kilo, deca. Sometimes you'll see this spelled with a C, sometimes you'll see it spelled with a K. I'm going to spell it with a C today. Whoops, and I've put that in the wrong spot, so let me erase that real quick. Whoops. Okay, so it should be kilo, hecto, then deca, and then we come to our base unit, and that's going to be your meters, liters, and grams. And then the next one that we'll encounter is deci, and centi, and milli. Okay, now I've written those vertically on purpose, just so that we can conveniently do a little vertical stacking and learning about that. So let's see. I'm just gonna put a few dividing lines in between there. and that will hopefully help keep things straight just a little bit. Now, kilo is actually a prefix that means 1,000. All right, and so if we have a kilometer, we literally have 1,000 meters, because the prefix kilo literally means 1,000. And so when you say a kilometer or a kilometer, you are literally saying 1,000 meters. You just are saying it in Greek and Latin instead of in English. So when we talk about kilo, that's 1,000. When we talk about hecto, that's 100. When we talk about deca, that's 10. When we talk about the base unit, that actually then is 1, or just the amount that it is. So it is what it is. Didn't get a straight line there. That's okay. Deci then is 0.1 or 1/10. Centi is 0.01, and milli is 1/1000th, which is 0.001. And so you can see that this is multiples of 10, and it's just like bumping the decimal along from one place to the other. So you can see if I took this milli and bumped it over one, I would have the centi. If I bumped it over one more, I would have the deci. If I bumped it over one more, and so on and so on. I want to point out something else that this does is kilo, even though it's 1,000, we could also express that as a power of 10, meaning 10 to the third power. 100 could also be expressed as 10 to the second power. 10 could be expressed as 10 to the first power. 1, of course, anything to the 0 power is 1, and so we could express that as 10 to the 0 power. Now, 0.1, 1/10. If I had 1 over 10, you see that would be actually the same as expressing that as 10 to the -1 power. Remember, because 10 to the first power, and then if I want to move it to the other side of the fraction, we just change the sign on the exponent. And so that would be the same as 10 to the -1st. All right, so I'm just going to, so I wanted to show you how that happened, but now I'm going to express that as 10 to the first, 10 to the -1st. So 10 to the -1st, this one is 10 to the -2nd, and this is, of course, 10 to the -3rd. So you can see that we have prefixes which stand for a certain power of 10 and a certain multiplier. Okay? But we can express that in terms of prefixes, or we can express that in terms, we can express it in terms of multipliers, or we can express that in terms of power of 10. So just as I had 1 kilometer, which meant 1 times 1,000 meters, because the prefix kilo means 1,000, I could also substitute kilo for 10 to the third. And that, of course, would still equal the same 1,000 meters that I had down here. And so we can see that those are equivalent. All right. So let's see. So let's look back at our 1,500 meters and see what we can do that. Hopefully you have these prefixes and roots and this little example copied down, because I'm going to now do my best to erase them all in one fell swoop. Let's see if I put that in a square and then hit delete and see if that does that. All right, great, it did. Learning something new about my technology every single day. All right, so let's go ahead and bring this over and say that I have 1,500 meters. And I would like to convert that into kilometers. what I'm going to do is I'm going to take my 1500 meters, and I'm just going to look at this little chart with my prefixes, and I'm going to say, hey, I'm starting with meters. Tell you what, let's switch to maybe another color. Let's switch to this kind of baby blue. So I've started at 1500 meters. Okay, and so that is my base unit. So I'm right here. All right, and I would like to go to kilometers, and I just need to say to myself, how many steps is that? This is one way to do that. And I say, okay, it's 1, 2, 3 little hops. Okay, 3 little hops to the left. So what I'm going to do is I'm going to take my decimal that I know exists there, and I'm going to hop it 1, 2, 3 spots, and so then I'm left with 1.5 kilometers. And that makes sense because if we took 1.5 kilometers and expressed that as 1.5, remember kilometer is 1,000 meters, then sure enough 1.5 times 1,000 would in fact be 1,500 meters. And so you can see that that 1,500 meters and that 1.5 kilometers are indeed equivalent amounts. Now, what if I wanted to take that same 1,500 meters but wanted to express it as centimeters? Okay. Let's see. Let's switch once again. We'll switch to a nice yellow color this time. So I want to go from 1,500 meters. Again, meters is going to be my base unit, so I'm starting off right there, and I'd like to go to centi. And so I'm going to look and I'm going to say, well, that's 2 hops to the right. So I will take my 1,500 and the decimal that I know is there, and I will hop it 1, 2 spots to the right, and then I'll fill in those spots with 0 placeholders. Okay? And so at this point, then I'm going to say, okay, 150, let's see, excuse me. Let me see if that's, yeah, sure enough, got the correct number of zeros, and that is 150,000 centimeters. Okay? So what I want to point out is if we start with one value, 1,500 meters, if we move to a bigger unit, like kilometers, because a kilometer is a bigger unit, if we move to a bigger unit, we will get a smaller number. But if you move to a smaller unit, like centimeters, a centimeter is about the width of your pinky fingernail, and so that's smaller than a meter, which is about a yard, and a kilometer, of course, is 0.6 miles. So you know, if you switch to the bigger unit, you get a smaller number, but if you switch to the smaller unit, you get a bigger number, because if you have a bigger measuring unit, there are fewer of them. If you have a smaller measuring unit, then you need more of them to cover the same amount. All right, so that's a quick look at the introduction of the metric system. Something else that I want to mention to you guys is that if you want an easy way to remember this KHDBDCM, there are all kinds of little mnemonic devices, little sentences that you can make up. The two that are my favorite are King Henry danced badly down Center Main. Okay, and you can imagine someone close to my age attending a TikTok dance party down Central Main, and it would be awful. It would be bad. But if you don't want to remember that, you can remember King Henry died by drinking chocolate milk. It's a little more morbid, but it's certainly a visual image that I think will stick in your mind and help you remember. So King Henry died by drinking chocolate milk. There you go, and that will help you remember that relationship between 1,000 and 1/1000th in terms of those. Just a couple of others that you may run into. A micrometer or a micrometer. is actually 10 to the negative 6th meters. Okay, and then there are some other prefixes and suffixes that you may run into, such as if you want to go to larger ones, we have mega, which is actually then 10 to the positive 6th, or giga, which is where the term gigahertz and gigabytes comes from, which is 10 to the 9th, and of course tera, which is 10 to the 12th. And if you go the other way, then you go from micro to, I believe the next order of 3 is pico. No, it's nano and then pico. But I'm not going to write that down because I am not 100% certain. I'm only like 85, 95% certain. So you can look up metric prefixes using Google or in a reference in your textbook. All right, let's clear that off again. And I tell you what, in fact, I'm going to clear the whole screen now, and we're going to move to something called dimensional analysis.